Welcome to the Tesla Crash Lab. Today we're doing a very special crash. We will be testing a pickup truck hitting a Model Y. As you see, it's a very small overlap. This is what we call an off-zone impact. This is the last piece of validation for what we believe is a world first.
Previously, the best way to design a safe car was for industry standard crash testing. And those crash tests are like a few grains of sand. Those grains of sand are meant to represent the beach, but in reality the beach is infinitely complex. Every crash is different. With emerging technologies, there are new opportunities. Now we can look at the real world and design for that.
We're the only car maker in the world that has a fleet of well over 1 million cars on the road, fully instrumented from a sensing perspective.
We can know exactly where the seat is, we can know where the steering wheel is, we know if they're belted, we know when the airbag deployed exactly to the millisecond.
We know exactly what our fleet of cars is being exposed to out there. The richness of data we are collecting enables us to develop safety beyond the stars and beyond the ratings, and for situations which is simply not picked up by the regulatory rating test that we and all other car makers are doing.
Industry standard crash testing is focused on impacts directly into the door. We've noticed in the field that it's very common for impacts not to hit the door.
Once we found the gap in what the legal testing required and the types of crashes we saw from our fleet data, we decided to use our very detailed simulation models to run impacts in different locations, like this simulation here. And we use this to really tune down to the millimeter and down to the mile per hour, the threshold at which you need airbags and you don't need airbags. We use that to tune the airbags and the seat belts for optimal safety.
Conventional systems don't detect this type of crash because it's not an industry standard. This new algorithm takes into account the current sensor set interpreted in a new way so that we can identify this particular type of crash and provide the optimum restraint for that situation.
After we ran hundreds of simulations, it was time to test this in the real world.
We have 17 high-speed cameras running at 1,000 frames per second, and camera data forms an integral part of the information that we collect in a big test like this. In the back of the vehicle, in preparation, we have our instrumentation rack, and it's got all the critical infrastructure to make sure we get all the data we need.
So what will happen is that when this pickup truck impacts the Model Y, so within 10 milliseconds of impact, the system will have determined what type of impact this is. And then it will trigger the airbag system and the restraint system to respond in the best possible way.
3, 2, 1.
So we just finished the crash test. Looks like we have a home run result. The cars even ended up exactly where we predicted. Post-crash, the detection worked perfectly, and we deployed the airbags exactly as we intended to, as we wanted to, and indeed as we predicted to. And I just had a look at the injury values recorded by the dummies, and they look beautiful. This feels awesome. This is history in the making, and this is really the end result of the entire chain of Tesla's strength in safety development, starting off with the field data, data analytics, lots of simulation, close cooperation between simulation engineers, design engineers, coming here to the lab, recreating this whole crash, performing it flawlessly, capturing the result. Now we have some post-processing to do to validate everything, but once that's done, this is in the pipeline for over-the-air updates to the fleet, improving the cars.
We have more data now than we've ever had before. We can understand real exposure, and then we can design our vehicles for that exposure.
We think over time this will change how you design for vehicle safety. It's all based on knowledge. I think this is just the beginning of a journey for us. The reasoning we're doing this is simple. It's because A, we have the ability, and B, it's because it's the right thing to do.